Let's look at your MT2, LT2, and 3 seminar on areas of regular polygons, circles, and sectors. Before you go any further, I'm going to pause the video and do the first 5 questions to either awaken your knowledge or to review in class. What I want you to learn today, we're going to spend the most time on the first one, is finding the areas of regular polygons. And we're going to find the areas of composite figures, which you've done before, so I'm not going to spend too much time on that in the seminar. We'll have a couple problems on your assignment. And we're going to find the areas of circles, which we've done before, once again, so we won't spend too much time on that. We're going to find the areas of sectors of circles, which are very similar to when we found arc length, but obviously we're going to be doing area. Now, like I said, we're going to spend most of our time on a regular polygon. A regular polygon, remember, has all the sides congruent and all the angles congruent. The center of a polygon is the center of your circumscribed circle. So the center of this circle is the center of my polygon. The radius of my polygon is the same as the radius of the circle. And notice I can draw in all these radii. Notice we have another new segment we haven't talked about. It's called the apothem. Spelled kind of weird, A-P-O-T-H-E-M. What is that? Is the height of the triangle that we made by drawing 2 radii. And that is kind of important because that's how we find the area of this shape. We're going to decompose it, notice, and we're going to have all these different triangles we're going to find the area of. Now, luckily, it's a regular polygon, so they're all going to be the same. So really, all you do is you find the area of one triangle, then you multiply by how many triangles you have. Now, we do have another term we're going to use because we're going to have to use some trig here, and that is your central angle. When you have 2 radii connected and you make your triangle, that angle in the center is your central angle. To find the measure of that, I just divide by the number of sides I have, because number of sides is the number of triangles I have. So I take 360, we're going to divide by the number of sides to find the central angle. And that's going to lead us to how you find the area. So you find the area of one triangle, you multiply it by how many triangles there are. So 1/2 base times height. In this case, my base is going to be the apothem. Or my height is going to be the apothem. I said that wrong. Your base is going to be the side of your triangle. What I'm going to do here is I'm going to multiply by the number of triangles. Well, if I take n times s, I get the perimeter. That's why you'll normally see the formula for a regular polygon is written as 1/2 AP. 1/2 times the apothem times the perimeter. Because what happens, I took 1/2 times base times height, but then I multiply it by the number of sides. That's where we get that from. So if we take a look at example 1 here, I'm just going to work with some vocabulary here. First, I want to identify my center. My center, we can see, is going to be R, the center of it. Let's name a radius. Now we have a whole bunch of them, but 2 of them are drawn in for us. So my radius goes from the center to the side, just like the radius of a circle, really. And since I drew the circle in here, it makes it a lot simpler. My radius would be RK. And then I want to name the apothem. My apothem is going to be the height of that triangle. So the height of my triangle is going to be RS. And then I want to name a central angle. Well, the angle at the center, angle KRL. So my central angle, remember when you name it, the vertex must be in the center. So it's angle K. Whoops, I can't write. I said it, but I didn't write it. KRL. You could name it LRK if you wanted to. And then we're going to find the measure of the central angle. Well, notice it's a hexagon. So it means there's 6 sides. So this central angle, I'm going to take 360. I'm going to divide it by 6. And my central angle is going to be 60 degrees. We want to find the central angle because I might have to find the apothem or the radius or the perimeter to answer a question. So all those depend on the central angle.